Today we have the lecture number 9, and this lecture is about the computer animation. And today I will also discuss about the project. I will show you one sample program, one or two sample program about the project after completing the lecture. So in this lecture we are going to discuss about the computer animation. We will see that what are the principle of the animations are there, and what kind of different animations are there, we will see. And if you recall that one of the simple animation we have already done in the lab, in which we have moved the rectangle from the top left corner of the frame to the bottom right corner. So this was animation in which we perform the translation or the motion of the object. So let's see what are the topic of this lecture. We will see the computer animation, what is the definition, what is the idea, what are the principles of animations, how we see that something is moving uniformly, consistently by using the sequence of the frames or the images. We will discuss about the very important concept in the animation, which is called the keyframe and the in-between. So in the animation, basically we are using the frames or the images. One type of the frames or the images are called the keyframe, and the second type of the images or the frames are called the in-between frame. We will discuss them. Then afterward, we are going to discuss the two type of the animation. One is called the constant speed animation, in which the speed remain the fixed, not changing. And the second is the accelerated animation, in which the speed is changing. We can increase the speed or we can decrease the speed. Usually increasing the speed is called the acceleration and decreasing the speed is called the deceleration. We are going to see some mathematical equations and some computation calculations about the constant speed animation, and also we will see some equations and some calculations about the accelerated animation. So these two concepts are quite important in the animation. So let's start the topic of this lecture one by one. First is the computer animation. Animation is the visual change over the time. So we are changing something, and if there is something there on the computer, the user can see the changes. Maybe some object is changing the position. For example, here you can see that we are showing the character which is moving or walking. So we say that the visual change over the time. So at some time we can show this frame. Maybe we can write this thing as a time t1. We can show the second frame at the time t2. So we can have something like a timeline, and over this timeline we are showing some sequence of the images which are doing something. Maybe they are doing some kind of motion or the movement, but there can be some other kind of animation can be there. We will see that. In the animation, a series of images are rapidly changed to create the illusion of the movement. We change these images very fast. Rapidly means we are changing these images very fast. Why we are changing the images very fast? Because we want to create an illusion that some object is doing some motion or some movement. If we are not doing the images change very fast, very rapidly, then it will not show the continuous or the smooth animation. It will look like that these images are separate. But when we are showing these images in a sequence and very fast, then it will create that these images are continuous and they are showing the continuous motion or the movement. But of course, it is required that these images are related to each other. What it means by related to each other means that they are making some changes gradually. For example, in these images, The character is walking. So he has to move the hands, the legs gradually. So the positions are changing step by step. So it is also important in the animation we are making the changes step by step gradually. And also we have to show these images very fast. How fast we will see that. Animation could display the time variation in object position, orientation, size, color or the texture. When we show the animation, we can change the many of the things. For example, we can change the position. Here the example is that we are moving the object. So this is the change in the position. In addition to the change in the position, we can also change the orientation. Orientation means that maybe we are rotating the object gradually on some direction, maybe like a anti-clockwise. So maybe each time we are changing the object by 1 degree. So these are change in the orientation. This will also be an animation. We can also change the size of the object. Maybe the object is increasing in the size gradually. So this will also be an animation. We can also change the color of the object. Maybe initially the color of the object is a black. All the values of the red, green and the blue are 000, and they are changing gradually to the 111, which is the white. So maybe we can change something like a point 0.1 every time for the red, for the green and for the blue. So they are going to be changed from the 0 to the 1 incrementally with the increment zero point 0.1. Or maybe we can change the texture of the objects, or we can change the illumination or the lighting. So we are changing something over the time period. So this is the concept of the animation. The most commonly used animation usually we are using is the animation we are in which we are changing the position. Some object is changing the position from one place to the other place. As we have seen in the lab, the rectangle was moving from the top left to the bottom right. Now there is some principle for the animation which is called the persistence of the vision. What is the persistence of the vision? Persistence of vision is the phenomena of the eye by which even the nanosecond of the exposure to an image result in the millisecond of reaction or the sight which we can see from the retina to the optic nerve. It means that when we show something to the human observer, if we show something for a very small time, which is something like a 10 power minus 9, which is like a nanosecond, and then we remove this object or this frame or this image very quickly, but the image will remain in the brain for the longer period of time. For example, it can remain for the time 1 millisecond. So this 1 millisecond is a bigger time. This nanosecond is a smaller time. So we show something for a very small time, then we remove it, but still the brain perceive it that the image is there. So when we do this thing for the sequence of the images, we show the first image, then we rapidly show the second image. So still the first image was there in the brain. Human can imagine that some image is there. Then continuously we show the second image, the third image. So these images are seem like they are connected and they are doing the continuous or the uniform animation, maybe like a translation or the motion. So because of this principle, we see the animation by the sequence of the images. Even though in the reality, this is not a motion, this is just independent images are there. But since we show them very quickly and they are available on the brain for the longer period of time, so that why we perceive them as a continuous motion. We use the word that we show these images very rapidly. How rapidly means that, for example, in the TV, if we see some program or some TV video on the TV, images are shown 30 frame per second. It means that in 1 second, we are showing the 30 images in 1 second. So for example, if there is a video for 1 second, we are going to see the 30 images. But if the video is for the 1 minute, then we have to multiply this thing with the 60, because in 1 minute there are 60 seconds are there. So we are going to see very large number of images. For example, in 1 minute, actually we see the 1800 images in just 1 minute video in the television. So a lot of data is being generated, and we are actually seeing a lot of images, and since these images are connected, we perceive them as a continuous motion. This rate, this animation rate is not the universal. There are some other standards are there. For example, the movies or the film on the DVD or maybe on the computer, they are using little bit lower frame rate, but still it is quite reasonable, 24 frame per second. So in the TV we are using little bit higher frame rate, and in the movies we are using a little bit lower frame rate. So this is the presence of vision phenomena by which we perceive the animation as a continuous. Now in the animation, when we are synthetically creating the animation using the computer, we are generating the frames. Some of the frames are quite important. Frame means like images or some pictures. Some of the frames are quite important, so they are called the keyframe. That's why we use the word key, means that they are important. So what we do in the keyframe, a keyframe is a detailed drawing of a scene at a certain time. So we are making this drawing. There can be some software can be there which can draw the drawing. Here right now the example for this keyframe is very simple. We just draw a straight line between the 2.1 and 2. So you can think that this is like our first keyframe, and by the some indexing by some variable we can call this free keyframe as a frame k. Now we have to draw many keyframe. For example, this is the second keyframe, and we are calling this keyframe as a k plus 1. So we are defining or designing some keyframe. Within each keyframe, each object is positioned according to the time for that frame. So when we are designing the keyframe, in the keyframe there can be the different objects can be there. So wherever we want to show these objects, at whatever position, we have to define their position of each of the object in the keyframe at a certain place by using some coordinate system, for example, x and y coordinate. So here in this keyframe K, we are representing just a single object, which is a line, by using the 2 point. Now in the next keyframe, we are making some changes to this object. Maybe we can say that the single line is broken into the two part. So we are representing the two line. The first line is from the point 1 to the 3 dash, and the second line is from the point 3 dash to the 2 dash. So there are some important frames are there. And the keyframes are defined at the significant position. So when we have our timeline is there, as I said that initially, in the keyframe, in the animation, we are using the concept timeline. For example, we can say this is like our time. So maybe we can show this keyframe at the time t1, important position or the important frame is there. Then we have some other time, for example, like a time t2, and we are going to show the second keyframe. So we have to show the keyframe at the important position, at the significant position on our timeline. So these are the important frames are there. In addition to these keyframe, there should be some more frames should be there, so that the changes are make like a gradual changes in the animation. Otherwise, if you look at these images, you will see that they are making quite rapid or quite abrupt changes. The line has been broken very abruptly in the middle. So in addition to the keyframe, we have to insert, we have to generate some additional frame. These additional frames are called the in-between frame. What are the in-between frame? In-between are the intermediate frames between the keyframe. So between the keyframe, we have to insert many in-between frame. For example, initially we have discussed that this was a first keyframe, and this was a second keyframe k plus 1. So between the first keyframe, which is a k, and the second keyframe, which is a k plus 1, we are generating, for example, first in between frame. So this is the halfway frame there between the keyframe. So in this frame, we are going to make the changes gradually. So you can see that initially the line is straight, then we have broken the line, but the slope is little bit smaller compared to the next keyframe. So we can insert many other keyframe between these many in between frame between these keyframe, So they are making the changes gradually. So usually typically there are 3 to 5 in between frames are there for each pair of the keyframe. So meaning is that, for example, if we have a keyframe K and the keyframe K plus 1, between them we can generate, for example, 3 in between frames sometime. We can generate sometime 5 in between frame, or maybe larger number depending on the choice of the animator, maybe 7, maybe 9. So it depends on the designer of the animation, how many in between frame he want to insert between the keyframe. Now when we are using the computer for generating the animation, the insertion of the keyframe or the calculation of the keyframe is done by the computer. The manual task is quite tedious or difficult. So we use some algorithm or some programs which are generating the intermediate frame or the in-between frame automatically by using some algorithm. So we have a keyframe systems are there. Keyframe system generate the in-between frame for the from the user specified keyframe. So what it means? It means that the user is going to provide the original keyframe and the in-between frames are generated by using the keyframe. So we are doing some kind of interpolation. As we have seen in the previous lecture, there are the different type of the interpolation equations are there. For example, we can use like a linear interpolation, a straight line, or we can use like a quadratic interpolation, or we can use a cubic interpolation to generate the in-between frame. For example, if we have to show some ball which is moving in a curve path, so initially we are going to design a keyframe at this position, maybe one keyframe at this position and one keyframe at this position. So this keyframe I can call this keyframe as a K, and I can call this keyframe as a K plus 1, and I can call this keyframe as a K plus 2. So between these keyframe, when we are providing this keyframe to the system, keyframe system, and we are using some equation for the spline, maybe like a cubic Bezier, these intermediate frames, they are going to be generated automatically by the spline equation. So whatever the position of the ball is there, it can be calculated by using the interpolation. So we can think that these are like an initial position. We can have something like a point P naught, and this is like a point P3. Many points are there, of course, just I'm giving one example. So we can use the interpolation with the different value for the parameter T. We can generate the multiple in between frame by using the keyframe system. So there can be the different equations can be there. One possibility is that we are using the spline or the curve like a Bezier curve, or other can be, for example, sometime we want to just use the straight line to show the intermediate frame which are being computed between the initial and the last keyframe. Now, after discussing this idea for the keyframe and the in-between frame, we are discussing the two type of the animation. One is called the constant speed animation. Another is called the accelerated animation. In the constant speed animation, speed is not changing. It can be a fixed speed. So if the motion is set to occur, if the motion is to occur at a constant speed where the acceleration is a zero, the equal interval of time spacing is used for the in-between frame. So when there is no acceleration, all the objects are moving with the fixed speed, then we are going to say this thing as a constant speed animation. In case for the constant speed animation, the interval between any two consecutive in-between frame is a fix, or interval between the first keyframe and the first in-between frame is a fix. We can call this interval as a delta. So either we measure the delta here between these two, or we measure the delta here anywhere, this is going to remain the fix. For example, if the value is here zero point 0.4 interval between the timing, so it will also be a zero point 0.4. For example, we can say the starting time is here 0, and then we have an interval zero point 0.4. So this point will be at a zero point 0.4. This will be at a 0.8 because the interval is 0.4. This is going to be like a 1.2. This is going to be like a 1.6, like this thing, because the delta is equal to 0.4. So we are changing the things with the equal speed. So this is the constant speed animation. Now for this constant speed animation, we are assuming that we are inserting the keyframe at the time t1 and our second keyframe is at the time t2. So the first keyframe we are calling the k and the second keyframe we call it k plus 1. Between these two keyframes, there are the many in between frames are there. So this is our first in between frame at this time. We have to insert the second in between frame at this time, the third in between frame at this time, the fourth in between frame at this time, and the fifth in between frame at this time. So here in this example, we are using the 2 key frame and we are using the 5 in between frame between the 2 key frame. So again, I say that this is our choice, how many in between frame we are using between the two adjacent keyframe. Now there are some equations are there for the constant speed animation. We will see that by some example. Suppose that we have to show the first keyframe at the time t1 which is equal to 10 and we have to show the second keyframe or the last keyframe at the time t2 which is 14. And assuming that we are inserting the 9 in between frame between the two keyframe. So we have to use some index for the in between frame which is changing from 1 up to the 9 because here n is equal to 9 number of in between frame. Then how we can calculate the spacing, the delta t between the any two adjacent in between frame by this equation. Delta t is equal to t2 minus t1 divided by n plus 1. So here in this our example, we have all of these values are available. We know the value for the t2, we substitute it. We know the value for the t1, we know the value for the n. So after substituting all of these value, our delta t is coming as 0.4. So the delta t is depending on the value of a t1, the value for the t2, and the number of in between frame. So this is coming here 0.4. So this is just the difference between any two consecutive frame. But what is the actual timing is there for any specific in between frame which is computed by the equation, this equation. So for any jth in between frame, we can compute the actual time by this equation t of bj. The time for the jth in between frame is equal to t1, the starting time, plus j multiplied by the delta t. We already calculated the delta t. So by this equation, we can specifically calculate the time for the jth in between frame. Let's see some calculation for this thing. For example, in the previous example, we were having the 9 in between frame was there and t1 was equal to 10, t2 was 14 and delta t was equal to 0.4. So if we have to calculate the timing for these 9 in between frame, so this is we have to calculate TP1, the first in between, TB2, the second in between, TB3, the third in between, by using the equation TBJ is equal to T1 plus J multiplied by delta T. So this T1 was the first key frame and the TB1 is the first in between frame. So by using the equation, this equation T1, we put the value T, J is equal to 1 for the first in between, delta T we already computed 0.4. So we calculate the time. We have to show the first in between at the time 10.4, maybe for example like a millisecond or something like this thing. So the first keyframe is shown at the time 10 and the first in between is shown at the time 10.4. Similarly, by using the same equation, just changing the value for the parameter j, we can find out the time for the second in between, which is called the TB2. So here in this equation, we are just changing the value for the j. The T1 remain the same and the delta remain the same. So we have to show the second in between at the time 10.8. Similarly, we can do the calculation for the third, fourth, fifth, sixth, seventh, eighth, nine in between frame. So this is the ninth in between frame is shown at the time 13.6. And then finally we have to show the second keyframe which is at the time 14.0, whatever second, millisecond units are there. So initially we have the time for the first keyframe, we have the time for the next keyframe or the second keyframe, and then by using the equation we calculate the timing for the in between frame in the constant speed animation by using the value of the delta t. Now after the constant speed animation, we are discussing the animation in which the speed is changing. For example, the speed is increasing. So this is called the accelerated animation. Speed changes are essential for many animations. Now in order to model the speed changes, we have to use some function where which is showing that speed is changing, where the time is not increasing uniformly. So there are the different type of the functions are there which can be used to uh, to model the accelerated animation. For example, we can use the trigonometric function like a sine theta, cosine theta. We can use like a spline function, natural spline, B spline, cardinal spline, Bezier curve like this thing. Or we can use some parabolic function or some like a circular function, hyperbolic function for modeling the acceleration, increasing the speed, or to model the deceleration or decrease in the speed. So here we are discussing about the acceleration where the speed is increasing. So we'll see that how we can model the increase in the speed by using the trigonometric functions. To model the increasing speed, time spacing between the frame is increased. In case for the constant speed animation, the time spacing was fixed. But in case for the accelerated animation, where the speed is increasing, we have to increase the spacing between the frame. The time spacing have to be increased. Why? So that the greater changes in the position occur as the object moves faster. So when we have a time which is increasing further, not with the uniform interval, then we have to show that object is making the more changes. For example, if the object is doing the motion, so it is going to cover the more distance, because if the speed is increasing, it has to cover more spacing in the given time, because the higher speed is there after every instant of the time. So in that situation, if the x-axis is the time, if we are going to use x-axis as the time, and along the y-axis, if we are showing the position, then increasing the gap along the y-axis shows or depict that spacing between the keyframe increasing. So it is going to show that the spacing along the y-axis will increase, which is showing actually that the position is changing more rapidly, and which is leading to the accelerated animation. Now, what are the equations are there for modeling this accelerated animation? We will discuss here in this slide. An increasing size for the time interval is obtained by the function 1 minus cosine theta. So basically, we are using this equation to model the acceleration, where we have to show that spacing is increasing on the timeline. So we have to use the equation 1 minus cosine theta. In this equation, the theta is going to vary from the 0 or greater than 0 and less than pi by 2. And we can write the equation for the theta, which is equal to j pi divided by 2n plus 1. And the time here, the delta t is not the same like a constant speed animation. Just want to show you in the constant speed animation, the equation for the delta t was a different. So this was the equation for the delta t for the constant animation, constant speed animation, t2 minus t1 divided by n plus 1. But in case for the accelerated animation, the equation for the delta t is different, which is equal to t2 minus t1, which is actually just the difference of the time between the two keyframe. The time for the first keyframe we have to show at the time t1, and the time of the second keyframe which we have to show at the time t2. And then we have to calculate the time for the jth in between frame. J can be any number from 1 to n. So initially j will be 1, then it will be 2, then it will be 3 until to the n. So j is actually showing that how many in between frame we want to insert between the any two keyframe. For example, the j can be 5 or the j can be 6. So equation for the jth in between is being given by the following formula. The time for the j in between is tbj equal to t1 plus delta t, which is this delta t, multiply by 1 minus cosine theta, because the theta is equal to j pi 2n plus 1. So rather than theta, we can write this thing. If we want to write the theta, we can write the theta rather than this whole thing. But we have to calculate the theta by using this equation j pi divided by 2n plus 1. So by this equation, we have to compute the time for every in between frame. So B is for the between and T is for the time and J is the index for the in between frame. A trigonometric accelerated function and the corresponding in between spacing. For example, here we show that suppose that we have the 5 in between frames are there. So our indexing for the J is going to change from 1 to the 5. So we have the index 1 for the first in between, we have the index 2 for the second in between, similarly 3, 4 and 5 are there. If we are showing these index along the x-axis and we are plotting our accelerated function along the y-axis, then what actually it will show? It will show that spacing along the y-axis is actually increasing. So if we are just going to show, for example, the first and the second and the third, so you can see that along the y-axis, initially the spacing was small, then it is gradually increasing. And similarly, if you are going to take the third value, it will show the more spacing. So this spacing is gradually increasing because in the accelerated animation, we have to increase the speed. So for example, the object is covering more distance after every instant of the time. Suppose that here in our example, we are using the value for the n is equal to 5. What it means? We want to insert the 5 in between frame between the any pair of the keyframe. Then according to our equation, we say that theta is equal to j pi divided by 2n plus 1. So we can put the value for the n to simplify the value or the equation for the theta. So once we put the value for the n, so we have equation j pi divided by 2 multiplied by n plus 1, n is equal to 5. So this 5 will be will be added with the 1 which is 6 and then 6 multiplied by 2 which is 12. So our equation of the theta will be a little bit simplified, j pi divided by 12 because we have the value for the n. Now by using the value for the theta, actually we have to compute the 1 minus cosine theta, and once the 1 minus cosine theta is computed, then finally we have to calculate the value for the t of bj, because the t of bj is depending on the t1 delta t. T1 is a fix which is not changing. Delta t we have to calculate only one time by using this equation, and 1 minus cosine theta is changing every time because in the equation for the theta the j is changing and j is changing every time. For example, for the first in between frame, j will be equal to 1. For the second in between frame, the j will be equal to 2. So now we have to calculate these timing for the in between frame. So here in our equation, n is equal to 5, and suppose that the timing for the first keyframe T1, suppose that it is equal to 0. We start at the instant 0, and the time for the second keyframe, which is equal to 6. Now once we have the value for the T1 and the T2, we can calculate the delta, which is equal to T2 minus T1. So 6 minus 0, we calculate the value for the delta. Now this delta will remain the fix. It is not going to be changed. But every time we have to calculate the value for the theta separately or individually for every in between frame. For example, when the j is equal to 1, we are going to put here 1 multiplied by pi divided by 12. So the theta is equal to pi divided by 12. After computing the theta, we are going to compute the 1 minus cosine theta. We know that theta is coming as 12 pi divided by 12. So we substitute the value for the theta in this equation, 1 minus cosine pi divided by 12. And the value for the pi is equal to 3.142. So we will write the value for the 3.142 value for pi. We are going to divide it by 12. Then we are going to compute the cosine of this value. So first we have to do this division. Then we have to compute the cosine. And then whatever answer is coming, we have to subtract from the 1. So 1 minus this answer. And the final answer is coming as 0.034, which is the answer for 1 minus cosine theta. But our main equation for the in between is equal to T of Bj is equal to T1 plus delta T1 minus cosine theta. Right now J is equal to 1. So we are going to put the value for the T1 which is 0 here. We put the value for the delta T which is 6 here. And then we are going to put the value for 1 minus cosine theta which is this value. So we are going to put the value here 0.034. We have calculated the time for the first in between, which is coming at 0.2045. So what it means? It means that our time for the first keyframe was equal to 0. Then after the first keyframe, we are inserting the in-between frame. So the first in-between frame will be inserted at the time 0.2045. Similarly, we have to change the value for the j. We have to calculate the value for the second in-between frame, which is shown here. We have changed the value for the j. Again, we have to calculate the theta because the theta was equal to j pi divided by 12. Now j is equal to 2. So we write here 2 multiplied by pi divided by 12, which is simplified to the pi by 6. Now we have to substitute the value for this theta in the equation 1 minus cosine theta. So we write here theta is equal to pi by 6. Then we write the value for the pi divide by 6. Then we find the cosine of this value. We subtract from the 1 and then we are getting the value of this uh, 1 minus cosine theta. So once we know the value for the 1 minus cosine theta, we can compute the time for the second in between TB2 equal to T1, which is fixed, delta T, which is fixed, and 1 minus cosine theta, which is coming from here. So we substitute the value, we are getting the value 0.804. So the meaning is that the second in between will be inserted at the time 0.80. Again, recall this thing. T1 was equal to 0, time for the first keyframe. TB1, the time for the first in between frame, zero point 0.2. The time for the second in between, zero point 0.8. So this is gradually increasing. Similarly, the time for the third in between, we have to calculate j is equal to 3. Again, in the theta, we have to put the value for the j by j multiplied by pi divided by 12. So we put the value for the j. We calculate the theta. We substitute the value for the theta in the equation 1 minus cosine theta. So theta is here pi by 4. And one important thing is there, which I write in every of these calculation. We are doing the calculation here right now in the radians. So I write this thing as a note. Angle calculations are done in the radian. What it means? When you do this calculation, because we put the value for the pi 3.142, we divide it by the 12. Then when we are calculating the cosine, so you have to use the calculator in the radian mode. So you have to keep the calculator in the radian mode. Then you are going to compute the cosine, because the value of the cosine is going to be different if you are using the calculator in the degree mode and if you are using the calculator in the radian mode. So when you are using this calculation, you have to keep the calculator in the radian mode when you are calculating this thing 1 minus cosine theta, because this theta is computing using the radian value. So the value for the pi, which is 3.142, is actually in the radians, not in the degree. So we calculated the value for j is equal to 2, then j is equal to 3, j is equal to 4. So we are doing all the calculations similarly. Just we are changing the value for this j in the theta. After computing the theta every time, we compute the value for the 1 minus cosine theta, which is coming here 0.5, and then we compute the time for the jth in between, which is the fourth in between frame, by using this equation t1 plus delta t 1 minus cosine theta. Every time we get the value of the 1 minus cosine theta, which we already computed from here. So we compute the time for the 4 in between, which is coming 3. Similarly, we are going to compute the time for the fifth in between frame. So if we are going to make some table in which we show our timing in the first row, time for the first keyframe T1, the time for the second keyframe T2. So these are the keyframes are there. So the T1 is 0, T2 is a 6, which is given. They are given to us. T1 is given, T2 is given. Then by using the equation, which equation? Every time we are using this equation to calculate the time for the j in between, by using this equation, we compute the time for the j in between. So we can create a table in which we are going to write the values for all of these in between. So the TB1, the time for the first in between is 0.2, the second in between 0.8, the third in between 1.7, the fourth is 3.0, and the fifth is 4.4. Now, if you are going to compute the difference between any two consecutive frames, you will find that the difference is increasing. For example, the difference between these two, the first keyframe and the first in between, is roughly 0.2. Now, if you are going to compute the difference between the first in between and the second in between, the second in between is 0.8, this is 0.2, so roughly this is something like a 0.6. If you are going to compute the timing here between these two, so this is 1.7, this is 0.8, so this is coming something like zero point 0.7 and zero point 0.2, something like a zero point 0.9 or something like a 1. So you can see that it was initially zero point 0.2, then zero point 0.6, then zero point 0.9. So the meaning is that along the timeline, the difference is increasing. So initially we draw the timeline. So if you see that this was the time for the first keyframe, so this was the time for the first in between, second in between, third in between, fourth in between, and the fifth in between. And these timings are gradually increasing. For example, the difference between these two and the difference between these two is quite different. So they are not the same. So in case for the accelerated animation, the difference is going to be increased. Similarly, if you are going to model the deceleration, the difference is going to be decreased by using some equation. So this was the calculation for the accelerated animation. Now, after this thing, I give you some sample problem or some sample question. So most likely that if I ask some question in some exams, the question may be like this question. So you should have some idea about this question, what kind of question can be there. So question is there, find the values of the animation intervals using the trigonometric accelerated function, fill the table shown below, draw the curve of the j, which is the index for the in-between frame along the x-axis, and the 1 minus cosine theta, which was the function to model the acceleration along the y-axis. Use the value of the theta in the radians given. We provide you the value for the pi 3.142. We provide the value for the n, which is actually the number of in-between frame we want to compute. So here in this example, we want to compute the 6 in-between frame between the two keyframe. We have an index j, which is going to be changed between the 1 and the n inclusive. Value for the t1 is given 0. The value for the t2 is given 7. Equation for the delta is t is given t2 minus t1. Equation for the theta is given, which is j pi divided by 2n plus 1. And the equation for the time to calculate the time for the jth in between is given tbj equal to t1 plus delta t 1 minus cosine theta. So after all of these parameters and equations are given, you have to fill out this table and you have to plot the curve in which the j will be along the x-axis and the 1 minus cosine theta will be along the y-axis. For example, you know that j is from 1 to n, and since n is equal to 6, so this one is very simple. You are going to write here 1, then 2, then 3, then 4, then 5, then 6. Then you have to compute the theta. By which equation? Which is given here. You have to compute the theta every time for every value for the j by using this equation. So equation for the theta is given. You can compute the value for the theta by this equation. And once you compute the theta, then you can compute the 1 minus cosine theta, because the 1 minus cosine theta is using the theta. So first you have to compute the theta, then you can compute the 1 minus cosine theta for every of these indexes. Then finally you can use the t of bj, which requires the 1 minus cosine theta and t1 and delta t. Then you can compute this thing. So once you are going to compute all of these things, you have to fill out the table like this thing. So this the solution is there. We have computed all of these things. Here right now, I also computed the theta in the degree. But as I say that, you don't have to calculate this thing. You just have to calculate the theta in the radians. You are going to compute the theta, you have to compute the j, 1 minus cosine theta, and the t of bj. So here when the question is given to you, I am going to provide you only one row for this theta, just one row. where you are going to compute the theta in the radians, not in the degree. And then finally, once you compute all of these parameters, then you can plot the curve. Here along the x-axis, we have the value for the j. So this is actually j, which is from 1 to 7. Actually, we are showing the 1 to 7 because this initially this 0 is for the T1, first keyframe timing, and this is actually for the T2. Actual plotting is from 1 to 6, which we are using here for the in between. So when you see the points, so you can say this point is actually showing the value of the 1 minus cosine theta when j is equal to 1. So actually what we are plotting here, let me erase this thing. So when j is equal to 1, so we take this 1, and the value for the 1 minus cosine theta is coming at 0.0251. So this point is actually showing this value, and this point is showing actually this value when j is equal to 2. This point is showing this value when j is equal to 3. This is showing this value when j is equal to 4. This point is showing this point when j is equal to 5. And this point is showing this value when j is equal to 6. So these are actually showing the points for the in-between frame. For the keyframe, we are not showing any value. We are just keeping as it is. So we are computing the values for the j, and then we are computing the value for the 1 minus cosine theta. We keep this thing j along the x-axis, and we plot the value for the 1 minus cosine theta along the y-axis. So this is the solution for this type of the question. So this lecture was a bit small lecture. As I say that I have to discuss the project. So after this thing, I am going to discuss the project. I will stop the recording here for the lecture and I will start the recording again for the project. So